Alright, so in this problem, they give you a vector and they want you to find the x and y component of that vector. So they give you the magnitude is 5.35 centimeters. So magnitude just means the length of this vector. And then they give you the angle, which is 307 degrees. So the first thing you do is you draw a graph. And just keep in mind that, like a normal graph, this side is positive, positive, this side is negative, negative. So, okay, so that'll be important later. So the first thing, and they'll specify where they want the angle, but in this one they say they started out on the x-axis, and they go all the way until the vector. So that's where the angle will be. So how you know which quadrant it is, and just if you don't know, this one's the first quadrant, second quadrant, third quadrant, fourth quadrant. So how you know which quadrant it is based on the fact that one of these between the intersections of the two axes, it's 90 degrees. So the first one would be 90, the second one would be 180, so just one half of a circle is 180. Here it'd be 270. So 307 degrees would be somewhere in here, because this would be 360, because a circle is completely 360. So this vector is going to be in the fourth quadrant. So we want to find the x and y component. So if it's 307 degrees, we can't really make a triangle out of that to use trig. So what we do is we make a triangle with a right angle. So we can do that because this one's at 307 degrees. So this tiny angle here will actually give us a triangle. So I've drawn that triangle here, and let me explain. So this one is the y component, right, because it's on the y-axis. All I did was bring this line over here, this component. So that's what I did. I just brought it here. So this comes from here, and I just shifted it to the right to bring it here, and that gives us a right triangle. So now we can start doing trig. So a really important thing to pay attention to is if the components are positive or negative. So like I said, these two sides are positive, these two sides are negative. I mean, you should have seen this by now in math. So that means that the x component, right, it's on here, the x component is right here, so they'll be positive, and the y component is negative, because it's right here. So now we know right off the bat that the x component has to be positive, the y component has to be negative. So now we can start doing our trig to find out the numbers for each. So we have the angle of 53 degrees, just transfer it here, and then the hypotenuse is just the longest side, so it's going to be across from the right angle. So it's going to be this one, the vector. So it's 5.35. And then what's going to happen is we have to label the opposite and adjacent side. So the angle right across from this is going to be the opposite side, and right here it's going to be the adjacent side. Because if this is opposite and hypotenuse, then this has to be adjacent. Okay, so I put here x because this is positive, and here negative. So just to make sure I don't forget, because that's really important. Okay, so this is the common expression, SOHCAHTOA, to determine if you need to use sine, cosine, or tangent. So let's look. So let's solve for the y first. So 53 degrees, so it's opposite, and the only number we have is 5.35. So we do opposite over hypotenuse. We look at which one that is, and we see opposite over hypotenuse, so it's going to be sine. So we have sine of the angle they gave us, 53 degrees, equals negative of the opposite, right, because this is going to be negative, over the hypotenuse, so it's 5.35. Okay, so now what you do is you just multiply each side by 5.35, cancel it out, and then you get, you multiply this by 5.35, and so you get 4.27 equals negative opposite. And then you just multiply each side by -1, and you get negative 4.27. So this is really important because that negative sign tells you which direction it's going to go. So the y component will be negative 4.27. So you make sure this is the y component by going back up here and checking that, oh, okay, opposite, which is the y component. So this is the y component. Okay, to keep going on, so we'll solve for the x side. So the x will be the x will be, so we just did opposite, which is y over hypotenuse. So if we want x, it's going to be adjacent over hypotenuse. So we can do that. So, and since we know it's positive, it'll be, we can take that into account. So it's going to be adjacent over hypotenuse. So we look at which one it is, and it's cosine. So we go down, and it's cosine of the angle, because the angle is 53 degrees. So we plug that in, and it's going to be, and since cosine is adjacent over hypotenuse, we put that. And then we put 5.35, because that's the hypotenuse. So we multiply each side by 5.35, and then, so that cancels out, and then you get 3.22, and it's going to be a equals that, and then you go back, make sure it's the x-axis, and it's the x component. So the x component will be this. It'll be 3.22. So I hope that helped, and thanks for watching.